an AI-generated post for your viewing pleasure. Transformer-based large language models have revolutionized natural language processing, but their voracious appetite for computational resources has hindered their widespread adoption. Now, a novel neuro-inspired approach could be the key to unlocking the efficiency these models desperately need. The meteoric rise of transformer-based large language models, LLMs, has undoubtedly transformed the landscape of natural language processing, NLP. These powerful models have pushed the boundaries of what's possible, delivering state-of-the-art performance on a dizzying array of tasks, from natural language inference to machine translation. However, their insatiable thirst for computing power has become a significant obstacle, limiting their accessibility and deployment, especially in resource-constrained environments. Enter Neuro Prune, a groundbreaking sparse training algorithm that takes inspiration from the workings of the human brain to streamline these language behemoths. By leveraging principles of preferential attachment and redundancy elimination, seen in the development of neuronal networks, Neuro Prune is able to induce structured sparsity in LMS, pruning away the computational fat while preserving their impressive capabilities. At the core of Neuro Prune's approach are three key innovations. First, the researchers tackle the multi-layer perceptron, MLP, layers of the transformer architecture, applying a weighted loan penalty that encourages a rich-get-richer dynamic, where the most well-connected neurons are maintained while the sparsely connected ones are pruned away. Next, Neuro Prune turns its attention to the attention layers, leveraging group sparsity to selectively eliminate entire rows in the query, key, and value matrices. This structured sparsification allows the model to preserve the most influential connections while discarding the redundant ones. Finally, the algorithm tackles the thorny issue of attention head pruning, a critical component for reducing the computational burden of LMS. Neuro Prune ingeniously maps this problem to the dominating set problem, a well-studied challenge in computer science, and devises a novel redundancy-based pruning strategy that biases towards keeping the last and middle heads in each layer. The result is a sparse training framework that is both model-agnostic and task-agnostic, seamlessly adapting to a variety of transformer-based architectures, including BERT, T5, and OPT, without the need for extensive architectural modifications. While previous efforts have explored various avenues for pruning and compressing large language models, Neuro Prune stands out for its principled, biologically inspired approach. Unlike earlier methods that focus solely on performance optimization, this new framework draws inspiration from the mechanisms underlying the development and refinement of neuronal networks in the brain. By embracing the concepts of preferential attachment and redundancy elimination, Neuro Prune is able to induce structured sparsity patterns that mirror the topological characteristics observed in brain functional networks. This not only leads to impressive performance on a range of NLP tasks, but also results in significant improvements in training efficiency and inference speed, addressing the key bottlenecks that have hindered the widespread adoption of these powerful models. Importantly, Neuro Prune's model-agnostic nature sets it apart from previous techniques that required extensive architectural changes or the introduction of additional variables. This flexibility allows the algorithm to be easily integrated into a wide variety of transformer-based LMS, paving the way for a new era of efficient and deployable language models. As the research community continues to grapple with the computational challenges posed by large language models, the insights and innovations offered by Neuro Prune could prove invaluable. By drawing inspiration from the remarkable efficiency of biological neural networks, this neuro-inspired approach holds the promise of unlocking the full potential of transformer-based models, ushering in a new era of accessible and impactful natural language processing.